Hi, everybody. It's Mrs. Dunn. We are about to start a marathon session. This section has a ton of learning outcomes. They are listed here. You can pause the screencast and read through them. I'm not going to read them to you. So I'm going to do 4 screencasts for this section. The first screencast today, the one you're watching now, in this one, we are going to cover these 4 learning outcomes. We're going to learn how to identify a quadratic function and a quadratic equation. We're going to solve a quadratic equation using the zero product principle. We're going to solve a quadratic equation using the square root method, and we're going to solve a quadratic equation by completing the square. So the first thing we want to do is talk about what is a quadratic function and what is a quadratic equation. So these are both outlined here. You can see this in your textbook. But let me point out a couple things here. Notice when we have a quadratic equation, there's no f of x. Notice that it's x squared. So a quadratic equation is going to have an x squared term. Notice when it's in standard form, it's set equal to 0. That's extremely important. Now, with a quadratic function, it looks exactly like this, except instead of saying equals 0, we say that this equals f of x. All right. Pay very close attention to what those quadratic equations are going to be looking like. So make sure that we have real numbers for a, b, and c. Make sure there's an x squared term, and make sure it's set equal to 0. All right, now let's get started. The first thing we're going to do is talk about this zero product principle. So I use this word a lot because it reminds me of my son. My youngest used to say that I was a mathematician, and I like that. I'd like to be thought of as a mathematician. So it's kind of like math magic. So I'm thinking of 2 numbers, and when I multiply these 2 numbers together, I get 0. What can you tell me about these 2 numbers? So if these 2 numbers multiplied together give you 0, one of them has to be 0. We use that idea when we solve quadratic equations. Let me show you one where like most of the work is done, you're almost at the end, and you have these 2 factors. 2x minus 3 times x plus 1 is equal to 0. Well, that zero product principle says if this times this equals 0, one of those has to be 0. So either 2x minus 3 equals 0 or x plus 1 equals 0. Well, on the left side, I'm just going to solve that equation, moving 3 to the right and then dividing by 2. So one of my solutions is 3 halves. And on the right-hand side, the other solution is -1. That means if I plug these 2 numbers into this equation, I'm going to end up with 0. So the 2 solutions are 3 halves and -1. All right, now we're going to use that principle to do this next question. So the next question says, solve 10x squared minus 16x plus 6. Well, we want that factored. We want to write that factored. So to factor this easily, remember from maybe if you took Math 085 or in your previous math class, you learned how to factor. So remember when we're factoring, we want to take out the greatest common factor. Well, the greatest common factor here is 2. Oh, I forgot to point out that this was in standard form, right? We see that it's in standard form, set equal to 0. So getting back to that greatest common factor, the greatest common factor is 2. So we're going to divide each of those terms by 2. And so what we have left inside is 5x squared minus 8x plus 3. Factor that. So factor that trinomial. It factors into 5x minus 3 and x minus 1. So If 2 times this equals 0, then either this parenthesis is equal to 0 or this parenthesis is equal to 0. So set those each equal to 0, and you'll get the solutions that x is equal to 3/5 or x is equal to 1. Those are the two solutions to the equation. All right, moving right along. So what we've done so far is solved a quadratic equation using the zero product principle. Next up is the square root method. So in the square root method, we start with an equation looking like this: 3x squared plus 21 equals 0. Can you tell what's different? Can you see how you don't have that middle term with just the x? Only with this type of equation, we can solve this using the square root method. So we're going to get our x squared term on one side and all the constants on the other. So for this one, I'm going to move positive 21 to the right-hand side. So I end up with negative 21. I still want to get x squared by itself, so I'm going to divide by 3. And I get x squared equals negative 7. So what I'm going to do in the next step is take the square root of both sides. Now the square root of x squared and then the square root of negative 7. Now when I take the square root of negative 7, I have to realize I'm going to get two solutions. So I'm going to get a positive, the principal root, and a negative root. So those two solutions are I times the square root of 7. These are imaginary. So it's x is equal to negative I square root of 7 or I square root of 7. All right, next up, we have this new equation: solve x squared equals 22 plus 10x. That's not in standard form, so we're going to put that into standard form, which is x squared minus 10x minus 22 equals 0. I sort of jumped the gun telling you we were going to complete the square, but at this point, the only method we have is the square root method. Can't do that because of that middle term, negative 10x. And we have the principle, the zero product principle. And we can't do that because we can't factor this. This expression is not factorable. So I'm going to teach you a couple ways to do that, completing the square, and in the next screencast, the quadratic formula. But in this screencast, we're going to solve this using the completing the square method. So to complete the square, what we want to do is get every term that has an x in it on the left and every constant on the right. So I moved 22. Now what I'm going to do is I want to add something to the left and add that same number to the right. And that number I want to add is going to make this a perfect square trinomial. Okay? So on this next screen, I spelled out what you have to do. So you want to take half of that negative 10 and square it. And that's the number you're going to add to both sides of the equation. So half of negative 10 is negative 5. And when I square negative 5, I get 25. So 25 is what I'm going to add to both sides. So notice I'm adding it in the parenthesis, and then I'm adding it to the right. That made the left side a perfect square trinomial. This factored is x minus 5 squared. And then 22 plus 25 is just 47. So now I'm going to use that square root method, and I'm going to take the square root of both sides. So when I take the square root of both sides, I get x minus 5 equals plus or minus the square root of 47. And when I add 5 to the other side, x equals 5 plus or minus the square root of 47. Those are our two answers. X equals 5 plus the square root of 47, and x equals 5 minus the square root of 47. All right, doing well. We got one last example in this screencast, and this is going to be a doozy. Solve by completing the square. Well, you can't complete the square here if you don't have a 1 as the... Okay, so we're going to solve this by completing the square. What I just said is that you can only use the completing the square methods if the coefficient of x squared is 1, and it is not. So what we're going to need to do is factor out that 3. So when we factor out 3, and this is kind of weird because 5 isn't divisible by 3. But when I divide each of these terms by 3, I get x squared plus 5/3 x. And then we're at that same point where we're going to have to add some number to both sides to make this a perfect square. So what do I add to both sides? Well, remember we want to take 1/2 of the middle term, 5/3, which is 5/6, and then we want to square that, which is 25 over 36. So I'm going to add 25 over 36 in here. Now, look, this says 25 over 36, but I didn't add 25 over 36 here. Okay, so where did I get 25 over 12? Why am I adding 25 over 12 here? Well, let me show you. I didn't really add 25 over 36 here because what is 3 times 25 over 36? 3 times 25 over 36 is 25/12. So that's what I'm adding to both sides, 25/12. It looks like 25 over 36 in here because we divided out of 3, but it's 25 over 12 on the right-hand side. Okay, so now we're going to add these two together. So 24 over 12, that's what 2 would be, plus 25 is 49 over 12. And on the left side, we have 3 times x plus 5/3 squared. That's what this would be factored. Now I want to get rid of this 3 by dividing by it. So when I divide, I get x plus 5/3 squared is equal to 49 over 36. 49 over 12 divided by 3 is 49 over 36. And I'm going to take the square root of both sides. So I get x plus 5/3 equals plus or minus 7/6. The square root of 49 is 7. The square root of 36 is 6. And so my two solutions are negative 5/3 plus or minus 7/6. Or I get x equals 1/2 and x equals -2. I actually did those two problems, negative 5/3 plus 7/6 and negative 5/3 minus 7/6. So the two solutions are -2 and 1/2. I know that example was a lot. So it's written there in front of you. You can pause the screencast. Just look at the steps that we went through. Look through the screencast again if you need to so that you fully understand it. All right. You definitely want to know how to do this by completing the square because it's going to come up again in Chapter 7. All right. Good luck. Email me with all your questions.